Today I am solving one of the problem from fluid mechanics, that is the Buckingham theorem, Pi theorem. Using Buckingham Pi theorem, show that the discharge Q consumed by an oil ring is given by Q is equal to N d to the power 3 phi bracket open mu divided by rho n d square comma sigma divided by rho n square d cube comma w divided by rho n square d close, where d is the internal diameter of the ring, n is the rotational speed, rho is the density, mu is the viscosity, sigma is the surface tension, and w is the specific weight of the oil. So how we can write is Q is equal to function of d n rho mu sigma w. Okay, so the Q is the function of all these terms. So the total number of variable 1 2 3 4 5 6 7, these are the total number of variables which is provided in this problem or which is mentioned in this problem. So n is equal to 7. So as a part of dimension, so the dimensions you must be knowing, or you have to have the knowledge of dimensioning, how the units comes. Or see the fundamental dimensions: length, mass and time, LMT. This must be remembered. So m is equal to 3 and n is equal to 7. So the number of pi terms what we get is n minus m. n is 7 and m is 3. So 7 minus 3 is 4. So the equation 1 can be written as function 1 is equal to, in the bracket, pi 1, pi 2, pi 3, pi 4, that is equal to 0. So we have to equate it to 0. So let us see how it will go next. Repeated variable should have geometric properties, second variable should have flow property, and third should have fluid property. So geometric property, flow property and fluid property, that are these three terms are very important. So which is the geometric property here? See, geometric property d. Why d? D is the internal diameter, it's a geometrical property. Flow property n, that is the rotational speed, that is flow property. And fluid property rho. Rho is the fluid property. You can see here the density is the fluid property. So these are the three terms that are repeated variable in this problem. So let us write the pi term first. Now the pi term: pi 1, pi 2, pi 3, pi 4. We have got 4 terms here because we have mentioned it here. See, pi 1, pi 2, pi 3, pi 4, the functions, 4 functions equated to 0. So initially pi 1, so which I said is d is a repeated function, n is a repeated function, rho is a repeated functions. Because see here, geometric property d, flow property n, fluid property rho. So these are the repeated variables d, n and rho. Here everywhere it is repeated. Here q, it's not repeated property, so initially we will be taking q, mu, sigma and w. Pi 1 d to the power a1, n to the power b1, rho to the power c1, q d to the power a2, n to the power b2, rho to the power c2, mu. For pi 3, this is the thing. So like that we have to write. So first pi term, that is pi 1, we have to write this equation: m to the power 0, l to the power 0, t to the power 0 on your left hand side is equal to l to the power a1, l to the power a1 into t to the power minus 1 whole to the power b1. Why, I will tell you. See here d and here d to the power a1. So d is L to the power a1, because for d the dimension is L. So here it is L. Power is same a1. For n it is written as t to the power minus 1. Here what it is, see, for n revolution per minute, rpm, revolution per minute. So 1 by n, minute is in terms of time, so 1 by t. So when it comes to the upper side, t to the power minus 1. So why it is t to the power minus 1, and b1 is same. Next rho is ml to the power minus 3. Here rho ml to the power minus 3, this is the dimension for rho, that is why it is written like this. And this one L3 t minus 1 for q, what it is written for q, L to the power 3 t to the power minus 1. So here it is written like that. There is no power for this one, because here only for repeated terms a1 b1 c1 is given, a2 b2 c2, a3 b3 c3, a4 b4 c4. For repeated terms only these are applicable, and for not these things. So now equating the power of mlt on both sides. So let us equate on the both side. So initially we will take the power of m. So here m is having 0, the power of m is 0. Okay, so the term m, here there is no m, here there is m. So what is the power of m? M power is c1, so we have to write c1. There is no m here, that is 0, so c1 is 0. Now the power of L, so power of L on the left hand side is 0, so it is 0, and on the right hand side we will see, so here is a L, the power is a1 minus, here is a L, there is no L here, so here is a L, the power is minus 3 into c1, that is minus 3 c1, so plus. Next here is L, there is an L here, so 3, so 3. So now 0 is equal to a1 plus 3. Why this becomes 0? Because here c1 is 0, so 3 into 0 is 0, this will be vanishing and only 3 remains, so plus 3. So a1 is equal to minus 3 after making manipulations. So power of t1, power of t, so here t to the power 0 on your left hand side, that is 0, that is equal to minus b1. Why? t to the power minus 1 into b1 is minus b1. Here there is no t, here there is a t, that is minus 1, so here it is minus 1. So after this thing you will get b1 is equal to minus 1. Therefore pi 1 this equation this one, pi 1 is equal to d to the power minus 3, that is a1. What is the a1? A1 is minus 3, so d to the power minus 3, because here a1 we have to substitute, here b1, here c1. So similarly a1 we are having d to the power minus 3. Next n to the power minus 1, that is b1 is minus 1, b1 n to the power b1, so here n to the power b1 minus 1. Rho to the power 0, that is c1 is 0 here, that's why it is 0. And q, so therefore pi 1 is equal to q equal to d to the power minus 3 n to the power minus 1. Therefore pi is equal to q divided by d to the power 3 into n to the power minus 1. This is what the value you get for pi 1. Similarly for the second one, same what we have to carry out here. Pi 2 d to the power a2 into n to the power b2 into rho to the power c2 into mu. That is what you have to write, and you have to substitute all these values. You have to substitute accordingly, and you have to solve the problem similarly what you have done here. The first method for pi 1, what you have done, similarly you have to carry out this thing, and you will get this answer. Pi 2 equal to mu divided by d square into n into rho. And for third term pi 3, same you have to carry out. See here, m to the power 0, l to the power 0, t to the power 0 equal to all whatever you are having here. Whatever you are having here, you have to substitute all those d value, d dimension, n dimension, rho dimension and sigma dimensions you have to enter here, and later power of m, power of l, power of t you have to carry out, similar to the first and second step, and same for the fourth step as well. And at the end, how you have to finish is substituting the pi 1, pi 2, pi 3, pi 4 values in the equation 2. You have to substitute in the equation 2. Here is the equation 2. This is equation 2. You have to substitute all these pi 1, pi 2, pi 3, pi 4 values equating to 0. And that is, see, this is pi 1 value, pi 2 value, pi 3 value, and pi 4 value. Everything you have substituted here, or later you have to do like this, and later at the end what you have to do is you have to prove that q is equal to d to the power 3 n phi into these values, these values which is given in the question. See here, you will get this value at the end after solving everything, each and every step. If you follow, then you will get the same answer which I have shown here, you will get this value similar to the given problem.